Hey, Bobette Hunsaker here, quarantine day number 52 or whatever. Not really sure anymore, but hey, so you just did some projectile problems. Today you're going to be doing problems involving area of rectangles. So the first thing that I want to say is, why, Ms. Hunsaker, can we not just guess and check? Why can we not just figure it out, right? And so this is the time when this is really super important, that you are understanding that you are in algebra class. And so it is all about the process. It is all about proving what works, proving that the numbers work, and that this is in fact the correct answer. Okay? And so, having said that, let me show you how this works, okay? So if you take a look at number 1, we are given this diagram and we want to find the value of x when the area is going to be 78, okay? Now, you can guess and check. You can absolutely do this in your head and see if you can figure out what the answer is. Maybe you think that you know it's going to be a 6 by 13, okay? And so let me just double check on my handy dandy calculator. Is 6 times 13 78? Yes, in fact it is. But here's what we're going to do, okay? We're going to prove it by using quadratic processes, okay? And so you know that we can either graph it, we can factor it, we can do completing the square, we can even do the formula, but we're going to prove that this answer is a 6 by 13 or a 6, okay? So here's what we're going to do. Remember, the area means length times width, so we're going to do x times x plus 7 and set that equal to 78, okay? Let's go start solving it. So I'm going to distribute. I'm going to move the 78 over, get everything on one side, 0 on the other, and then I'm going to factor. And I know that the two numbers that are going to multiply to give me negative 78, that are going to give me 7, those two numbers are 13 and 6. Using my rules of factoring with quadratics, I know that this answer is going to give me a negative 13. This answer is going to give me a positive 6. Now, negative 13 does not make sense because you can't have a length that is negative. And so 6 is definitely our choice. Let's go read the problem one more time. The problem says, find the value of x. And so I'm done. X equals 6. Okay, let's go do it again. Number 2, given the diagram below, the dimensions of the rectangle, find the dimensions of the rectangle. So this time we want the dimensions, okay? I want the length and the width, and I want the area to be 108. So again, same thing. I'm going to write length times width and set it equal to 108. Let's go distribute. Let's move the 108 over, and let's go find numbers that multiply to give you 108, that add to give you 3. I know that those numbers are 12 and 9. Be super careful about your symbols. Watch your signs. You want it to be a negative 3, so make sure it's a negative 12. Okay, so I know that this answer is going to give me positive 12. This one's going to give me negative 9. Can't be a negative. I want the dimensions, and so I know x is 12. 12 minus 3 is 9. So my dimensions are 12 by 9. Okay? All right, let's do it again. Number 3. This time, our length and width are 2. And so please make sure that you're putting them in parentheses. They're 2 binomials. Okay? And the area is 128. So you're going to have to do some foiling, some hardcore foiling. It's been a while. So we're going to get x squared, positive 7 minus 1 is going to be a positive 6x minus 7. We're going to move the 128 over, and we get a negative 135. The two numbers that are going to multiply to give you 135 that are also going to give you 6 are going to be 15 and 9. So it's x plus 15, x minus 9. I know that my two possibilities are negative 15 and positive 9, but negative 15 is not going to work. The question again says find the dimensions. And so when I take my 9 and I go back up here, 9 plus 7 is going to be a 16. 9 minus 1 is 8. Be super careful that you don't fall into the trap of, oh, I got a 6, and 6 and 7 is 13, or oh, I got a 12, 12 and 3 is 9. Be careful that you don't fall into that trap, because sometimes your dimensions are different, okay? All right, number 4, same thing, different idea. It's just in a word problem, and so same thing. I'm actually going to go ahead and pause the screen and finish this problem for you. If you want to go ahead and do the same, pause the screen and see if you get the same answer. Not a bad idea. Okay, so I went ahead and FOILed, moved my 60 over, found my two numbers, got rid of the negative 1. I went back and highlighted what it wanted me to find, which was the value of x, and since I did that, x minus 12 equals 0, x is 12, we're done, okay? All right, number 5. So number 5 is a little bit different. It says that the length of a rectangular garden is 4 meters more than its width. So I don't know about you, but I think I need a picture. And so I'm going to draw that. So the length of a rectangular garden, it's 4 meters more than its width. Well, here's its width, W, right? And so the length is W plus 4. Oh, look at that. Not too bad. Okay, and so now we're going to go ahead and multiply them. So W times W plus 4 equals 60. The final problem or final question says to find the dimensions. I want to make sure that I finish that up. All right, I'm going to go ahead and move my 60 over. Let's see, when I factor this, oh, plus 10 and minus 6. So I know you guys have been working really hard on doing the quadratic formula for a little while, so you get kind of a little break with this and you can practice your factoring, okay? Okay, so dimensions, I want dimensions. So I want 6 and 6 plus 4, which is 10. So the dimensions are 6 by 10, okay? All right, number 6, length of a rectangle is 6 meters less than its width. I think I need another picture again, so let's go try this one. Here's my width, 6 meters less than width, so I have to take W and subtract 6, okay? All right, and I want the dimensions if the area is 27. So I'm going to go ahead and multiply these and set it equal to 27. Let's subtract our 27 over. W minus 9, W plus 3, positive 9, negative 3. Negative 3 is not going to work. When I put this over here, I get 9. 9 minus 6 is 3, and so 9 by 6. Okay? Again, be careful. Make sure that you don't fall into the trap of just calling it, right, and getting those answers. So just be really careful with that. Okay? All right, let's go check out number 7. So while this is here, consecutive integers is coming up next. So don't worry about numbers 9, 10, 11, and 12. We're going to go do numbers 7 and 8, and you're going to practice some area problems today. Okay, the consecutive integer problems are for another day. All right, so here we go. Number 7, we have a square that is altered. And so what I think I want to do first is I want to draw a picture. Here's my square. Okay, I know that with a square, the side lengths are the same. So I'm going to go ahead and draw that. Let's see, it's altered. One dimension is increased by 5, the other is decreased by 2. If the area of the resulting is 98, find the area, of the original square. I like this question. Okay, so let's go change this rectangle, okay? And so one dimension is increased by 5. Let's just make it this one. The other dimension is decreased by 2, so x minus 2. The area of the resulting is 98, so I'm going to go multiply these two together and set it equal to 98. When I get done, I'm going to get an answer for x, right? When I get all the way done, I'm going to get an answer for x, and then I'm going to know what the dimensions of my square were, and I'll be able to find the area of the original square. Okay, let's go FOIL this out. So we get x squared, let's see, minus 2 plus 5, so that's plus 3x minus 10. Let's subtract that 98 over and factor. Okay, and I get a negative 12, positive 9. Well, it's not negative 12, it's definitely positive 9. So I know that my original square was a 9 by 9, and so it looks like the area is 81, because that's what length times width is. So there's my final answer. Okay? All right, let's take a look at number 8 and see what's going on with number 8. So given the diagram to the left, if the area of the shaded region is 59, what are the dimensions of the outside rectangle? So I want to know what this by this is. The area of the shaded region. Well, how do we get the area of the shaded region? So we're going to do the area of the large one, and we're going to subtract the area of the smaller one. Okay, and that should equal, it says, the area of the shaded part. So I'm going to do the area of this big one, and I'm going to take the little guy out, and that's supposed to equal 59. Okay, so let's go figure this out. What is the area of the large one? Well, the area of the large one I have to multiply together. 2x minus 1 and x plus 6. So that expression is 2x squared plus 12 minus 1 makes an 11. Okay, let's do the smaller one. And so I have an x by x plus 3, and so that is x squared plus 3x. Now I skipped a little space for a reason. I know that I'm going to have to be subtracting, and so I just moved it over so I could line stuff up. So I'm going to subtract these two things. So 2x squared minus x squared is x squared. 11x minus 3 is 8x. Negative 6 minus nothing is negative 6. And all of that is supposed to equal 59. I'm running out of space, so I'm going to squeeze this up here, I think. So let's go move that 59 over. So x squared plus 8x minus 65. 65. What goes into 65 is going to give me 8? Ooh, I got it. 13 and 5. Okay, and so I'm going to get an answer of negative 13 and positive 5. Well, negative 13 is not going to count, right? It's definitely going to be a negative 5. Let's go double check the question one more time. What are the dimensions of the outside rectangle? I'm going to use a 5. And so I'm going to get 5 plus 6, which is an 11. Put a 5 here. 2 times 5 minus 1, that's a 9. So the dimensions of my outside rectangle are 11 by 9. Holy bananas. All right, your job is to do numbers 1 through 8 on the other side. Keep in mind, consecutive integers are coming soon. So you're going to do 1, 2, 3, 4, 5, 6. On the next page, 7 and 8. Numbers 9, 10, 11, and 12 are consecutive integer problems. Okay, let me know if you need any help.